Let's continue on with Java conditions. Let's talk about testing. In testing, you will execute all paths through the program. Recall the flowchart we saw earlier. A good idea to test all combinations of ampersand, ampersand, and a pipe, pipe. When numeric ranges occur, test the values around the change in behavior. It's not always necessary to test all possible values, and in most cases is impossible to test exhaustively. Within this presentation, let's discuss now other conditional statements, and later on we'll talk about comparing data. Let's discuss the if-else statement. An else clause can be added to an if statement to make an if-else statement. For example, if condition, you'll execute statement 1, else statement 2. So what that's saying is, if the condition is true, statement 1 is then executed. And if the condition is false, statement 2 is executed. Keep in mind that one or the other will be executed, but not both. Now let's look at our diagram of the logic of an if-else statement. If you remember our diagram from earlier in the presentation, it was not as complex as this and had what looked like a single path. Here you will see that you have your condition being evaluated, and if it's true, you move on to statement 1 as it did in the first diagram. However, after your condition is evaluated, and if the condition is false, you then move on to statement 2. Take a moment to look at the diagram and review the different conditions. Let's look again at indentation. Remember that indentation is for the human reader and is ignored by the computer. Now here's an example of what not to do. You have basically your statement. It's lined up, but if a programmer comes in after you have coded this, it may cause confusion as to what your intentions were. So despite what is implied by the indentation, the increment will occur whether the condition is true or not. Block statements. Several statements can be grouped together into a block statement delimited by brackets. A block statement can be used whether a statement is called for in the Java syntax rules. Take a look at the example below. Continuing with block statements. In an if-else statement, the if portion or the else portion or both could be block statements. Take a look at the example below. Do you see how you have your statement within the brackets in the if section of the code and in the else section of your code? Take a moment to look over the code and make sure you understand how it is laid out. Nested if statements. The statement executed as a result of an if statement or else clause could be another if statement. These are called nested if statements. An else clause is matched to the last unmatched if, no matter what the indentation applies. Braces can be used to to specify the if statement to which an else clause belongs. The switch statement. The switch statement provides another way to decide which statement to execute next. The switch statement evaluates an expression, then attempts to match the result to one of several possible cases. Each case contains a value and a list of statements. The flow of control transfers to statements associated with the first case value that matches. Continuing with the switch statement. Often a break statement is used as the last statement in each case's statement list. A break statement causes control to transfer to the end of the switch statement. If a break statement is not used, the flow of control will continue into the next case. Sometimes this may be appropriate, but often we want to execute only the statements associated with one case. The switch statement. Take a look below at the example of a switch statement. The switch statement. A switch statement can have an optional default case. The default case has no associated value and simply uses the reversed word default. If the default case is present, control will transfer to it if no other case value matches. If there is no default case and no other value matches, control falls through to the statement after the switch. The expression of a switch statement must result in an integral type, meaning an int or a char. It cannot be a Boolean value, a floating point value, float or double, or another integer type. The implicit Boolean condition in a switch statement is equality. You cannot perform relational checks with a switch statement. Next, let's take a look at comparing data. Comparing data. When comparing data using Boolean expressions, it is important to understand the nuances of certain data types. Let's examine some key situations. Comparing floating point values for equality, comparing characters, comparing strings in alphabetical order, and comparing object versus comparing object references. Comparing float values. You should rarely use the equality operator, two equal signs together, when comparing two floating point values, float or double. Two floating point values are equal only if their underlying binary representations match exactly. Computations often result in slight differences that may be irrelevant. In many situations, you might consider two floating point numbers to be close enough even if they aren't exactly equal. Comparing float values. To determine the equality of two floats, you may want to use the following technique. Take a look at the code below. If the difference between the two floating point values is less than the tolerance, they are considered to be equal. The tolerance could be set to any appropriate level, such as 0.0000001. Comparing characters. Java character data is based on the Unicode character set. Unicode establishes a particular numeric value for each character and therefore an ordering. We can use relational operators on character data based on this ordering. So for example, the characters single quote plus single quote is less than the character single quote j single quote because it comes before it in the Unicode character set. Appendix C in your book provides an overview of Unicode. Comparing characters. In Unicode, the digital characters 0 through 9 are contiguous and in order. Likewise, the uppercase letters A through Z and the lowercase letters A through Z are contiguous and in order. Take a look at the chart example below. Comparing strings. Remember that in Java, a character string is an object. Equals method can be called with strings to determine if two strings contain exactly the same characters in the same order. The equals method returns a Boolean result. Take a look at the example below. In the code, you have if name1 equals name2, then the system will print the line same name. Comparing strings. We cannot use the relational operators to compare strings. The string class contains a method called compareTo to determine if one string comes before another. A call to name1 compared to name2 returns 0 if name1 and name2 are equal. They contain the same characters. It will return a negative value if name1 is less than name2. And it returns a positive value if name1 is greater than name2. Comparing strings. Here's the information we discussed in the previous slide, but written into code. Because comparing characters and strings is based on a character set, it is also called a lexicographic ordering. Take a moment to review the code. Lexicographic ordering. Lexicographic ordering is not strictly alphabetical when uppercase and lowercase characters are mixed. For example, the string great comes before the string fantastic because all the uppercase letters come before all of the lowercase letters in Unicode. Also, short strings come before longer strings with the same prefix. Therefore, book comes before bookcase. Comparing objects. The operator can be applied to objects. It returns true if the two references are aliases of each other. The equals method is defined for all objects, but unless we redefine it when we write a class, it has the same semantics as the operator. It has been redefined in the string class to compare the characters in the two strings. When you write a class, you can redefine the equals method to return true under whatever conditions are appropriate.